I'm expecting it to be about an hour long. If it goes over a little bit, that's fine. I do have a student at 4:30 though, so I can't go over too much more than the hour. I've had actually a very busy teaching day. So I will be looking at things we can do sort of a little bit mentally to get ourselves better at chemistry, and then some actual practical strategies, because I know what you don't want is for me to just say, oh, just, just think positively. That's not how you get an A star. You've got to take action. You've got to do things. Okay. And so, as I said, a few of you have told me like what year you're in, and now I'm going to ask you some other questions which you can answer, privately in the chat, because you might not want to necessarily have everybody looking at your goals, etc. So, and these are some of these questions I asked you in the email that I sent with the Zoom as well. So you're a little bit primed. Okay. So my number one question, which I think is definitely worth reminding ourselves about, especially if you're in year 13 right now, why are you doing A-level chemistry? That may be a question that you ask yourself every time you wake up in the morning or every time you turn up in the in the lesson. Um, I think it's very important that we remind ourselves why we're doing this. Okay. Um, Linked to that, maybe, do you have a goal? So it might have been that you kind of fell into A-level chemistry, or it may be that you have a very specific goal, such as medicine, such as natural sciences. What's your aim? And again, as a teacher, you obviously had a reason that you chose to teach A-level chemistry as well. And then alongside that, while we're trying to remind ourselves why we are putting ourselves through this not insignificant challenge, um, what is it that's challenging about it? What for you is perhaps maybe getting in the way? What made you come here on a half term thinking this A star is not guaranteed, or this A is not guaranteed, or this university place is not guaranteed? What is it that's difficult that you are finding getting in your way? So I've got some people giving me answers right now, which is fantastic. I'll tell you a little bit about myself, um, just while you're thinking of your answers to those three questions. So I am indeed a chemistry teacher. I've been tutoring since 2003, and I qualified as a teacher in 2006. So there you go, nearly 20 years of qualified teaching, but more than 20 years of tutoring and also teaching in like private schools, etc. But I didn't start out with my A levels thinking I was going to be a teacher. I actually did all three sciences at A level: biology, chemistry, physics. Um, and I did that after doing GCSE double award science, which was quite a step up. And I did it for pragmatic, kind of practical reasons, mostly because I either wanted to be a scientist or I wanted to be a writer. So like write novels. And my reasoning, I was quite a sensible teenager, was that I could write a novel anytime, in theory. But if I wanted to be a scientist, I had to do a degree in science, so I would need to have to get some formal qualifications, whereas I didn't necessarily need a formal qualification to do a novel. So I kind of put that in a maybe I'll do that sometime. And no, I haven't written one yet. Um, so I wanted to be a scientist, and I did do a double honours degree at Southampton, and I love my science. And actually, I realised while I was doing it, while I was doing scientific research, that actually I really enjoyed explaining science more than I enjoyed doing it. Even though I do love it, I really enjoyed communicating it. And so, therefore, I changed career into being a teacher. Teaching's not all I love, loads of things I enjoy doing. And I think that's what we should all remind ourselves, is that we've got lots of, we're all like unique people, which is why I'm not trying to do like a one size fits all. So we've got, I like chemistry, want to do natural sciences. Oh, took it as a fourth subject. And the difficulty says about key fact recall. We will definitely talk about recall today. Enjoyed it at GCSE, good idea. Wanted to get into healthcare, but the exam questions are tricky. even though I understand the content, we will definitely look there at the difference between like understanding and application. Had to take it alongside bio. Oh dear, you had to take it. Okay, would like to study dentistry. Oh, I see what you mean. Right, so you had to take it for dentistry. Um, just thinking you're not good at it. Okay. We will definitely talk about what we think about chemistry today as well. Going to medicine or chemical engineering. Cool. It's nice to have more than one goal. Finding it difficult to remember content and effective revision. Perfect. Well, we're definitely going to talk about that today. Um, and I want to go into a career in forensic science. Cool. So you need chemistry for that. Understanding content and applying it to exam questions. There's a lot about exams being difficult. There's a lot about recall. Veterinary, possibly. Not wanting to be too stressed. Yeah, we'll definitely talk about stress today as well. Finding the maths difficult. Okay, cool. Well, not cool that you're finding maths difficult, but you know what I mean. The mark scheme, having the knowledge but not knowing the mark schemes. Struggling with technique and mark schemes. Yeah. Found it interesting. It certainly is the such an interesting science. Um, and it's one that you need for uni. So there's definitely a situation where a lot of us need this subject, or like we feel like we need it. Um, and you feel like you're maybe memorizing things, but it's not quite getting there. You might have got the predicted grade you want, but maybe we're worried that we're not going to quite get there. So what I love is what I've got a really big range of people here, and I really like that because I think one thing that I really love about being a private tutor now. So was teaching in different schools all the way up to 2023, and it's only in the last 2 years that I have been full time working from home. And part of that is health reasons, but part of that is also I really, really appreciate being able to give people a more individual approach, either in small groups or one to one than you get in a school. But don't worry, I'm not selling my private tuition because I'm booked up. Um, and we are all unique individuals. You know, that's one of my happy places is being in front of my periodic table. But other of my happy places is being up mountains. I really enjoy hiking and traveling. And another happy place is dancing for me. So I'm in the back left. I'm not one of the pretty people in the front, but I took part in a choreography recently, and that was just it was the only decent photo I could find that involved me dancing, but I'm not actually dancing in it. So lots of things are challenging, but it does make it worth doing. And a lot of people have mentioned the challenges that they've had. Now, I think one of the issues, someone said, like some of the forms were talking about fear and being held back and just generally going, I'm just not good at it. Okay. So I think we've all been in that situation. I've been at it myself in A levels. So one of the things that I said is I started and I did double science, not triple. That's just because that's all my school did. There was no option for triple science in my secondary school. So I was sort of missing a chunk of science before I went on to do three sciences at A level. And then there was the other thing, which is I went from a sort of very basic state school. It was not terrible, but it was not particularly high achieving, into a slightly more high achieving sixth form. And one thing I want you to realize, especially if you're in year 12 and you are feeling overwhelmed right now with the speed of it, or if you've got to year 13 and you thought you were okay in year 12, but actually, whoa, that was a lot, you realize just how much you forgot. Um, is to realize that every time you take this step up from GCSE to A level and then from A level to university, you are putting yourself in a smaller, self-selecting group of people. When you did GCSE science, everybody did GCSE science, whether they liked it or not. You might have been in a top set. You probably were. But even in that top set, not everybody wanted to do science or went on to do science at A level. So you're already in a group of people who chose the subject, which is nice because they probably behave better than they did at GCSE. But You are now in a group of people who probably, on average, did a lot better than the GCSE class you were in before. And if we looked at the like numbers behind it, like a huge number of people who do are doing A-level chemistry, they would have got 8 or above in GCSE. And 8 or above is a really good GCSE pass. But now everyone around you's got that. And that means that your really good GCSE pass maybe doesn't feel quite as special as it did before. Okay. Also means that you're really not guaranteed to get a really high A-level pass. So if you look at the number of A stars and A's, even from students getting 8 or above, only 57% of students who got an A star above or 8 or above at GCSE, and this is separate chemistry, not double science, are then moving and able to get the A star and A. So there's obviously a bit more selection going on at this stage, which is obviously we can't give A stars and A's to everybody, but hopefully the techniques that I'm talking about today will bring your grade up regardless of where you are at right now. Um, so the idea is that it's likely you're not going to feel as smart as you did at GCSE. That can hit people hard. Um, it's also going to happen when you go to uni, you know, if you the more difficult the university that you choose to get into, when you get in there, you are going to have that feeling again. So you've got to have some strategies to get around that. Um, and what this is an issue that can happen. I'm not saying that everybody in here is in this boat, but certainly from my perspective, because I've also taught in an independent school for 12 years, which was selective. And so everybody who's in an independent school, if it's selective or grammar school, that kind of environment, you've got that extra selection process. So there's a whole, like, I don't know, 90% of the population that you're not even seeing, that you don't know about. And it can make you doubt your own abilities. Um, so this is the kind of thing that I would see happen a lot um, in a high performing school is that everyone around you, and this happens at sixth forms as well, our expectations and standards are higher than they were for GCSE students. And so, you know, your teachers are going to be teaching faster. They are going to allow less time for recap, also because there's just more material to do. And they are now teaching to a little subset of what they had at GCSE. So rightly, they're teaching at a higher level. But because of those high expectations, if you've got very high expectations of yourself because you've always been well performing, and it is statistically the well performing students that go on to do A-level sciences, then you are likely to have a little bit of perfectionism. Okay. So I do. And it's something I've been working with like a lot for the last 20 years or so. And you can also feel a little bit of imposter syndrome. So you may be thinking, I'm not sure if I'm good enough for chemistry right now. I'm not sure if I'm good enough to get into the university I want to, if I'm good enough for medicine, if I'm good enough. There's a lot of enoughs going around in our brains. Are we working hard enough? Are we good enough? Are we fast enough? Are we like getting enough percentage in our tests? And the problem with like, so it's good to have high standards. It's good to want things to be correct. Accuracy is important in science. It's important to see details, etc. But if you are naturally that kind of person, we can get a bit in our heads. And what can happen then is if we feel like we shouldn't be in a place and we're not good enough, we start to avoid things. So we start procrastinating, we start putting things off, or we do things, but we procrastinate in a different way. So we actually are doing something, but it's just busy work and it's not effective, and we're just doing something for the sake of it. And we are avoiding any kind of discomfort because we don't want to feel like we're getting things wrong. So we avoid getting things wrong in a safe place, like in a lesson, which should be a place where we can get things wrong. And then, of course, because we haven't had that opportunity to go wrong, because we haven't kind of stuck our neck out and actually tried it, that's when our grades will start to obviously fall. It might not even be that. It might not be the avoidance. It might just be up in your head as to why your grades are falling. But the moment they start to not be as good as they were before or not good at GCSE, we start to see that pattern because we're naturally good at spotting patterns. We start to think about too far into the future. We start to get anxiety. Anxiety is just going to make us procrastinate even more. And then our grades are going to fall even more. And you might not even know that this is happening because anxiety can manifest in all kinds of different ways: headaches, stomach aches, tiredness. Doesn't have, it feels different in different people. Procrastination can manifest in different ways. And this ability to sort of ignore tasks and stuff like that. We can all just say we're very, very busy. So by being aware of that, so I had a few students who put in the questionnaire, oh, this is really hard. Like, I just find I'm not doing anything because I don't know what to do and I'm overwhelmed. That's first of all, be aware of it. And first of all, be aware that it's completely normal. That's kind of seems to be a part of just being alive in 2025 right now. Okay. So we have to give ourselves some mental tricks. One thing we can do is try to boost our motivation and try to enjoy chemistry again, or at least have a reason. We need to remember that's not the journey, okay? It's not a straight road from here to where you're going. You might, and if we think it's going to be like that and then it's not like that, we're going to get very easily disappointed. Journey's more like that. This was, I don't know if anyone's driven a road like this. This was last year. I went to Montenegro and it was like a mountain road and we were just trying to get from one place to another. And it didn't say it was very long, but that's what the real road is like, okay? There's a lot of times in life where you can't see around the corner and it's a lot harder than you expected. Um, so I didn't go the route I wanted. I became a teacher. Um, when I became a teacher, I thought that I would probably be a teacher and then a head of department, and then I would probably become an assistant head, maybe. But that didn't happen either. Lots of things change in your life. So to get motivated, before we move on to some techniques and things, because I want you to be in a good place, um, think of something that you used to find hard that you now find easy. Okay, because I think we can all think of one of those things in chemistry. It might be anything, balancing equations. Do you remember how hard balancing equations was when you were like back in year 10? Or just anything to do with chemical equations, because we didn't practice it a lot at GCSE. And anything that you personally are proud of, like, and it doesn't even have to be chemistry related. And also, sort of based on that, what advice would you give yourself if you were starting GCSE again? Because we know ourselves. So I often ask my year 13 students as they are finishing or on results day, what advice would you give? Or sometimes at the beginning of year 13, it's always good to hear from year 13s, what would you advise a year 12 student to do now that is maybe different to what you did at the beginning? So yeah, Alima says shapes of molecules is something she found really hard. And if you're doing shapes of molecules now in year 12, you probably do find it really hard. Now it's pretty easy. Used to find Hess cycles hard. Absolutely. Oh my goodness, how hard were Hess cycles when you started them? Then you do Born-Haber cycles and you're like, oh, actually Hess cycles were fine. Maths calculations. Absolutely. So there's a load of things, and it's really nice that I'm getting some stuff, I think, from year 13s right now who are saying that they used to find this difficult at the start of year 12, but now are finding it a lot easier. Uh-oh, you haven't done the year 13 Hess cycles. Don't worry, they're easier because they're predictable. Um, nice. Yeah, so organic synthesis routes, brilliant, and being able to remember organic reactions. So some advice, we've got reading ahead. Um, And so, absolutely, yeah, reading ahead, but also reading back. That's going to be the biggest advice. So, of all the students that I've taught, they've not all got A stars. I'm not like that good, because I don't actually have control over all the students. So I can't actually, make them all get A stars. So yeah, bonding, something that people used to find hard as well. Learning all the triple content. Wow. Okay. Practicing more. Everyone says practicing more. Okay. Revising a little bit every day. God, you guys are experts already. Okay. And time management, starting revision early. Practice past papers repeatedly. I'll talk about past papers. So yeah, of all the students that I'm saying that are getting the A's and the A stars, and also, of course, that does mean that I have taught students who have not got those grades. So everybody's a unique individual. At no point have I ever noticed really any correlation between the grades and gender, race, economic background, the country they're in, or anything like that. There's no real correlation there because every student is unique. So I have taught abroad as well, and I have taught international students. I've taught students in like a really big sixth form college. And as I also said, I've taught students in a slightly more elite independent school. So these are themed across all of those environments, not just for rich kids or I don't know, like really smart kids who get all nines. So one misconception is that students who are highest performing, that they don't somehow, that it still sometimes just goes in, they look at it once. Now I can say I probably have less than one student per year for who this is true. Okay, so proper photographic memory and ability to remember stuff, it's not that common. Okay, so I would say most definitely those students that are getting the high grades are doing regular practice to remember stuff, like you said, and it's active. Second biggest thing, just I'm trying to find the politest way to say just cock up often, all the time, get it wrong, and try to let go of caring about getting it wrong. Okay. When I do one-to-one tuition and I'm talking or I'm in a group, if I ask a question, I have many students, including one who I taught this morning, who is in like ridiculous tiny percentage. Like she got a Rowentium prize, which is above gold in the Cambridge Chemistry Challenge. So she's super good at chemistry. She still struggled on some of the questions I asked her this morning, and she still got some stuff wrong, but she always talked about her reasoning. She spoke out loud, she thought about the chemistry, and when she went wrong, she didn't have like a big flap about it. She kind of consolidated the information and realized and changed her understanding. So, willingness to get things wrong is the only way we can get things right in the long run. Also, making yourself practice under time conditions. So somebody mentioned past papers. Past papers are not going to be much anywhere near as useful if you do them all looking at your notes, or you just do them and you give yourself as much time as you need. Like at some point, you will need to. It's not every time. It's after you've done the other practice that you need to practice exam technique under time conditions. And you need to actively seek that feedback and ask questions. So another weird misconception, I think it's mostly a younger pupils, and I hope it's not amongst you guys, but I don't know, is that people who ask lots of questions are like somehow stupid or not getting it. You find ask most teachers, they will find the opposite. The students that are asking, it shows they're engaged, it shows they want to understand it, and it shows they're thinking about how it fits in with everything else. There's also attention to detail. Yep, gotta love being pointed out a mistake. That's how I know my student's going to get an A or an A star when they point out my mistakes, because we all make them. And your teachers should not be stressed about you pointing out mistakes. If they are, that seems like they may be feeling a bit worried about their own abilities. Not arguing, but just pointing out it's easy to make a mistake, especially when you're writing on a board. And then synoptic thinking, and that is so the ones we're going to focus on, the retrieval and the willingness to get things wrong is they go together because the more you practice something, the more you're going to get wrong because that's just statistics, right? And if you only ever practice easy things, you won't be prepared for hard things. So you therefore are going to have to get stuff wrong. And the more you expose yourself to that, the better you are going to be. Um, the more you ask why you got it wrong and you seek feedback and you look at all the details in the mark scheme, the less you will get it wrong next time, and the more you will see your attention to detail. So, attention to detail comes with practice. It also comes with a certain brain state that you're not anxious, that you're not so worried about your performance that you miss all the stuff that's actually going to help you perform. So, attention to detail is what's there when your brain isn't distracted, and your brain can distract itself very easily. And synoptic thinking, we are going to look at how we can revise to help that. So, that's linking things together. So, I have a little true or false question. Um, so, if you understand something well, it will stay in your long-term memory. What do we think? True or false? Just give me a T or an F. I've got what we got. True, false, true, false. Oh, true. This is like true. More likely, or like it, true, and true, and true. Okay, so more true than false, and I suppose it's a bit of a sneaky little question. It's not a true or false question, is it? It's not as simple as that. Someone said, yeah, most likely, more likely to stay in your long term with active recall. Brilliant, Divine. Thank you. So, this thing that's underneath is very, very small. That there, that's my name, or it's my name before I got married. So, I contributed to this paper while I was doing the research that I was doing for my master's. And so I must have understood it, right? It's literally my research. It's not even something that I've read in a book and, then written about. That's literally my original research that I carried out in a laboratory with somebody else helping me, sure, but I was part of a group. I helped write this paper. Yeah, I don't understand like half the words in it. Like, because it was 20 years ago. So, yes and no. Certainly, if you don't understand something, it's much less likely to stick. You can make things stick, even if you don't understand them. And there is a trick in chemistry to knowing which is more important. Okay, so but certainly without the practice, nothing will stay in your long-term memory, no matter how important it was at the time. So I'm going to give you a quick memory challenge. Make sure you're paying attention right now, just in case you were looking at your phone or something. Um, I want you to remember these four words for later on. Okay? Red, cat, tree, bone. Four words. Red, cat, tree, phone. Simple words. Nothing complicated. Got it? That's all you get. Red, cat, tree, bone. Now let's talk about retrieval practice. So, if you are on my mailing list, you will already get my retrieval practice quizzes. Give me an honest thumbs up if you do them every week. You might not know about them, you might have only just joined or whatever. So I know that some teachers use them in lessons, but the whole idea is that students can use them yourself. So the point of the quizzes, of all this kind of what retrieval practice is, it's doing the practice of getting stuff out of your memory, because actually a lot of things that are in there And I know they're in there because I asked students and they're like, I know this is an obvious question. I'm like, yes, it is an obvious question. You've only forgotten it because you haven't practiced bringing it back. Okay. So retrieval practice is about getting information out, not reading, not watching videos, but actively doing things. And what people do wrong is they think that retrieval practice is getting one of these flashcards, which are great, and going, huh, quick questions. Which subatomic particles would you find in the nucleus of the atom? Oh, yeah, I know that. Let me check. Yeah, got it right. Mm. If you didn't write it or say it out loud, you did not retrieve it. You think you did. If you don't write down an answer or say it out loud, you are not actually retrieving properly. You are just going to make your brain feel better because when you turn the card over, you're going to think that you got everything that was on that card because your brain's going to do that because it likes to make you feel good. So it has to be a little bit harder than just imagining the answer. Imagining is better than nothing. That's better than just reading a book. But doing a question, when you get to a 6 mark question, you're like, oh yeah, yeah, I think I know how I'd answer that. I'm just going to look at the mark scheme and check. No, you are taking too many shortcuts there. Okay. So if you don't like writing or we don't want to waste paper, just use a whiteboard. Um, Flashcards, just talked about them. So using them properly means if you are trying to practice, so flashcards are great for like definitions, and that's what things like my retrieval practice do. My retrieval practice quizzes are things just like definitions, do a quick calculation, that kind of thing. Simple practice questions, so not big involved exam questions, but simply name this molecule, do this calculation, find out these moles, etc. Oh, found somebody popped in late. Where you will find good practice questions, apart from the quizzes and things like that, is in your textbook, right? So at the end of chapter, those kind of things. And then this is something I played with yesterday, um, because I said, unless you are writing or talking, you're not doing something active. So talking is great. And I think we don't do, well, I do it a lot because I'm a teacher, literally, it's my job. Um, but I think as students, we don't do it enough. How often do you actually talk in a chemistry lesson? Um, I am reckoning that some of you might go a whole hour without saying anything. It depends. Or, how can I put this? Not saying anything chemistry related. Slightly different. So, um, and why this works well, I did a little practice exercise yesterday. So, um, voice to text is a really great tool that is available like for free anywhere. So most phones have a voice to text capability, and Google Docs has this as well. So Google Docs is free. You can open a document and you can click on tools and you can open voice to text. So this is what I did yesterday. Um, and explain how you could use this in your revision to give yourself a different activity which will make you work a bit harder on retrieval. I turned on the voice to text and I decided that I was going to talk for 1 minute. So I set a little limit on my phone about a topic that I was pretty confident about. Now, I'm a chemistry teacher. So the one that I chose was first ionization energy. Okay, so that's 1 minute of me talking about what first ionization energy is and what affects it. And I actually ran out of time. I could have gone for about 5 minutes probably because I just did a lesson on it the day before. So, and I thought, well, that's great, but I'm going to show this to some A-level students and they're going to be like, well, great, yeah, but you can talk about first ionization energy because you've talked about it for 20 years, so you know what it is. So then I was like, okay, what about if I choose something that I'm not very good at? So, or that I know something about, which would be you guys with A-level chemistry, but there's gaps, or I'm not as confident. So I then took the boys to text for another minute and I decided to try and talk about like magnetism and generators. So it's something that I know something about. I do teach GCSE physics. It's just not my comfort zone. So I pushed myself out of my comfort zone and tried to talk with no notes or anything and no warning. So I hadn't revised this, I haven't taught this for probably about 6 months. So this is what I tried to say. First of all, I called it the inductive effect, which is not what it is. The inductive effect is something chemistry related, which I got mixed up in my mind. So all the green is where I either got something wrong, or missed something out. So I said induces a current. I should have said alternating current. Um, I said it cuts through right angles, whereas I just talked about a magnetic field and I don't really know which thing it is. So using it in a question, I said make a current instead of induce a current, so that wasn't right. I don't even know what I meant when I said it happens the opposite way. The yellow highlighting is where I just repeated myself. So I just already said about turning a coil of wire through it. So I was repeating myself a lot. I was getting a lot wrong. But what this did is it really quick. It was a minute. Doesn't take very long to show what's going wrong. And I had this idea because this is something that happens when you do one-to-one tuition. I ask questions, students come back to me and they get an opportunity to talk. And when they get the opportunity to talk, I can hear the mistakes they're making and the problems. And we can look at them together and unpick misconceptions. So, this is a really good strategy, especially if you hate writing, but you just want to test your understanding of something without getting the sort of wrist cramp. And if you want to test yourself a bit more under pressure, especially if you do biology as well and you've got those essay questions, have a go at using voice to text. So, with retrieval practice, which of these do you think? And the other things that I've mentioned, we're going to move on to how we think synoptically and making links. But so far, we've looked at these ideas. So, using more quizzes, asking questions. This could be asking questions in class, asking questions by email. Doesn't have to be right there in the lesson. Could be making up questions, practicing under timed conditions, so actually making yourself do things under proper exam conditions and getting super uncomfortable about it. And voicing things out loud. So actually speaking the subject that you're doing. The reason that I'm saying that speaking is useful, and I understand the irony when I'm just talking at you and you're using the chat, is it's another way to use your working memory and it our we have two different channels if you do psychology in the brain. You've got a visual channel and you've got an auditory channel. They are both able to process information together, which means that if you've got speaking and visual, it really supports what you're doing, as opposed to only visual. So yeah, a few people have talked about speaking chemistry out loud. Also, it's very non-threatening, right, to just talk to Google. A little word about ChatGPT. You can do this to ChatGPT as well. Don't ask ChatGPT to help you with any calculations at all. It can't do even very basic maths. Okay? If you want to use ChatGPT, ask it to ask you definitions, but make sure you tell it what exam board you're doing, right? And be really clear. Don't just say, I want the definition for X, Y, Z. Like, say, I want the AQA A level chemistry definition. Then it will test you, or make it ask you simple questions. That is fine. It's no good for deep questions and it's no good for calcs. Okay, thinking synoptically, joining things together. So, this is a really big one. This is why it's kind of the subheading. Um, Making links between topics. That's all it means. I mean, the word syn means like bringing together and combining. So synthesis means making something, joining something together. Synapses, classic biology link, that is like the join between two neurons, right? Um, so true or false? You might not know if you're only year 12, you might not know much about the structure of the A-level papers, but typically we think about A-level paper 3 being like the synoptic one. And the reason that we think that is because that's the one where it can test any topic. Um, oh, good. I'm glad that you. Well, the fact that you're here, I suppose, does mean you are a slightly self-selecting audience in that you've realised that thinking synoptically is super important, regardless of which exam paper you do, right from the beginning. So, yeah, I'm not expecting you to be able to read all of this, don't panic. So, one reason that thinking synoptically is important is because real exam papers are synoptic all the way through. This is paper two. It's got an organic focus. It's AQA paper two from a couple of years ago. But in a single question about technically it's about biofuels, but there's a hydrolysis question. There is a complete experimental question about enthalpy changes. There is a empirical formula question, and then there is an environmental question. And then later on, there's a rates question. And then later on, there's an equilibrium question. So all of these things are all interlinked. And I wouldn't be surprised if somewhere there was a question about bonding or shapes or intermolecular forces. So you can't just keep going to save my exams or physics and maths tutor or whatever you're using and go, oh, just give me questions, please, on biodiesel. I don't want any questions on anything else, just that. It's not going to work. Um, so thinking synoptically, the other reason it's important is in what it does with your memory. So here's a test. What were the four words that I asked you to remember? Oh, I just realised that you could have cheated and written it down. I hope you didn't, or screenshotted it. Nice. Look at you all go. Okay. Not only did most of you remember it, but I think you're just messing with me, Emma. Not only did you all remember it, or nearly all of it, but most of you remembered it in the same order as well. So yeah, the words were red cat, tree, phone. And Sargon said, yeah, I just imagined a red cat near a tree with my phone. Fair enough. I imagined a red cat stuck up a tree, and then I was using the phone to call the fire brigade to help me get the cat down or something. Maybe perhaps not quite so dramatic. I was just using the phone to tell the red cat's owner that they were up a tree. So by linking, we made that a lot easier. Okay. So the other reason why thinking and linking your topics together is so important is because it gives you less to remember. And this happens all the way through. We just don't notice it's happening because it's happening to us. So if I asked a year 10 student right at the beginning, like they only just done a little bit on atomic structure and bonding, and I said, what is the charge on a sodium ion? Let's think about all the knowledge you need to answer that question. That year 10 would want to look at a periodic table because they probably wouldn't remember what group sodium was in. So they'd go and have a look and they'd see it was in group one. Then they'd have to think about atomic structure and think, oh, I think it's got two and then eight and then one. So it's got one electron in its outer shell. Then they would have to think, what do metals do? They lose electrons. So it would lose one electron. Then they would have to think, what charge do electrons have? They have negative, so when you lose it, it's positive. And back when you first learned that, that's what your brain would have been doing, going over it, and like it would have taken quite a long time. Now, I asked my year 12 last night, what's the charge on sodium ion? They're like, +1. Exactly. All of that's been removed because they've linked all those concepts together and they've rehearsed so many times already that they know it. Though they don't, when they come to an exam, need to work out, oh, it's a charge on sodium ion. Like, I'm gonna work it out, look at my periodic table. They're not wasting that time. So a lot of the time, that's why the retrieval is so important. So that you've rehearsed definitions, so that you've rehearsed formulae, so that you've rehearsed organic naming, so that you're not spending so long trying to work all of that out. Once you've done that rehearsal and then we link things together, once we've got the links, I could ask you what's a potassium ion, also plus one, what's a lithium ion, plus one. I don't need to work anything out anymore because I know all the links. So you can only learn stuff if you build it on stuff that you've already know how to do. And that's another reason why thinking synoptically is important. So I'm going to give you 4 different examples of things you can do. Not necessarily, not past paper stuff. Past papers are very synoptic, yes, but we need some in between stuff. Can't just keep doing past papers because we don't know all the topics yet. So this is one, chemistry improv. Somebody give me a compound. Just name a compound. You give me the formula if you like. Any compound. I'm just going to take the first one. Oh, crikey, like 3 of them came up at once. Okay, I'm going to take my favorite. Uh, ooh. Oh, it's just so exciting. I don't know now. I'm gonna go with NaCl simply because it was actually genuinely the first one. Um, I could have gone with many. I did like the potassium manganate. That was a nice one. All right, so NaCl, sodium chloride. What can I find out about it? I can find out bonding, structure. What else does it link to? Tests for ions. So most of us will need to know the test for chloride ions. If you do Edexcel, you're also going to need to know about flame tests. We could have some mole questions about that. It's a salt, so I could link to acids and bases, and I could look at some equations to make sodium chloride. I could prepare it by evaporating the water from a solution, which also relates to its solubility. What else do I need? If I know it's ionic, then if you're very lucky, you will have done about Born-Haber and lattice energy. So I'm linking it to energy changes. And if I'm linking it to energy, I can link it to enthalpy of solution if you've done about that as well. So already I found all of these links for sodium chloride. If I just went with sodium, I could talk about first ionization energy of sodium, like atomization of chlorine, all sorts of different things. I could do balanced equations. The formation of sodium chloride, I could talk about redox. I could talk about displacement because there's a chloride in there which contains a halogen. So I could look at displacement, redox, oxidation, loss of electrons, gained, the whole lot. So anything that you do, you just take anything you like and see how many ways you can link it to your other topics. What I recommend, especially if you're beginning of year 12 or if you're in year 13, is to start looking at every topic that you've got from the start of the year, because those are the ones we forget, and actually think, where else is that linked to? What does that link to? How many ways can I link them together? Okay, another one which I do, like I've done this a lot in classes as well amongst students, like working in groups. Comparison questions. So someone asked about like 6 markers. Comparison questions, we tend to focus on differences and not similarities. And comparisons are good for things that have similar ideas but are different, and to try and organize our thoughts around it. So, for example, electronegativity, which you might not know yet if you're in year 12, and ionization energy. So, those two have a lot of similarities. So, they increase across a period, they decrease down a group, They measure attraction to electrons. So that's why they have similar trends. But I could also say how they're different, and that will stop me. So the reason that we then put the differences column is to stop us using one when we mean the other. So ionization energy is only for forming an ion, and electronegativity is only for covalent bonds. So, like, there are some important differences. I could also look at a calculation one like this. So often we only ever revise calculations by doing the calculations instead of what the terms mean. Percentage yield versus atom economy. I could look at the similarities. Well, they're both percentage. They're both related to like how much product. And because they're similar, that's when we can confuse them. And in a question, I can't remember which one's which. So I could talk about the fact that yield, you need actual results. You need to know how much you get out. Whereas atom economy, I'm just going to write AE, you need like only the balanced equation. And there are so many different ways that you could do this. Rate constant versus equilibrium constant, what do the K's have in common? How are they different? Any functional group, organic chemistry is super synoptic. Um, and so this is a great way. I feel like when we look at organic chemistry, I mean, hats off if you've already been learning all of your organic reactions. The best way to learn them all is to try and link them together so you can see what is similar and what is different. And the great thing you can do with that is you can just pick any organic molecule. So this is a third possible activity. Pick an organic molecule and ask yourself all those questions about it. Don't worry, you can go back and look at it afterwards. Um, all of those questions, name it, identify the functional group. There might be more than one, so just pick a random picture of an organic molecule from an exam paper. This is how you can use an exam paper without using all their questions. You don't need all their questions to do this kind of synoptic thinking. These are the kinds of questions they're always going to ask you. What is it called? What type of reaction does it do? What strongest eigenmolecular force does it have? What's the biggest bond angle in that molecule? What kind of shape does it have? What are the isomers? Types of isomerism? Does it have structural or functional group or stereoisomerism? Like, what's happening with that? What chemical tests can you do? And different ways of drawing it. This is something that really sets apart the higher level if you're thinking that you always struggle with organic questions. Drawing that upside down, up, like draw it sideways, draw it displayed, draw it structural. Don't just stick to the one thing that you like doing for an organic molecule, because otherwise you're in your comfort zone. And yeah, not just what things it does, but how do you get to an aldehyde? So I can talk about what an aldehyde does. It can be oxidized, it can do addition, but I could also say, how do I make an aldehyde? I could start with an alcohol and oxidize it. So you are then working back and linking it to all the other different topics. Oh, love it. After doing this activity, would you identify your weaknesses and then go over the specific points? Absolutely. Always you need to obviously get some answers. So make sure that you are confident with checking and going over the specific points. Yeah, I would possibly, anytime that you're doing things like this, using just a little stack of post-it notes and making a point of, I need to revise this. That is definitely a habit of people that are going for A and A star, is to say, oof, that is an area, like when you get a test back, that is an area I need to just recap a bit more. Or saying that is something I don't understand. And that's different, right? Identifying when you're doing a question, is it because you didn't understand it, that topic? Or is it because you just didn't revise it enough and you just need to recap it a bit more actively? For less organic things and for calculations, it might feel like that you can't really do that for calculations. Like, how are you supposed to make up your own calculations questions? Easy. Just take an equation and make up 5 questions about it. Even better, and this will allow you to really think about how calculation questions work. I call this activity 1 to 5. And what I want you to do is question 1 is 1 mark, question 2 is 2 marks, and question 3 is 3 marks, and so on, and build it up until you could like make up a 5 mark question. And just like it's difficult to do without something to look at. So just pick an equation and just be like, okay, 1 mark could be like calculate the MR of calcium carbonate. 2 marks could be calculate the mass of calcium chloride if you have this many grams of this. 3 marks could maybe make it into a percentage yield question. They're quite often worth 3 marks. 4 marks, getting trickier. Maybe put a practical question in. Maybe a volume of gas. Okay, 5 marks. Try writing a back titration. You've only got to make up numbers and put them in. Okay, um, and then you are then encouraging yourself to work on it. Obviously, if you can find like lots of practice questions, like end of topic questions in uh, textbooks, that's better because you'll have the answers. But you can see that by making yourself make up questions, you are really putting yourself much more in a position of being in control and reducing some of that fear factor. And you can do this with your mates as well. So these are things that I often did with groups and activities. Okay, I'm already at 4 o'clock. I have actually gone through most of the activities. So anything, mind mapping is great. So making links is good. But mind mapping, what I find is people just want to put everything in a little box and they don't want to have any lines crossing over. And that's not really how the subject works. So don't make a mind map with the aim of it being beautifully laid out and color coordinated. Make a mind map with the aim of making as many messy lines between things as you can and riding over the lines. It is not to be pretty, it is to engage your working memory. Working memory goes into long-term memory. You have to do something with the information to store it. You have to link it to something else to store it. So the more that you do that, the better. And the thing is that, yeah, we will say you need to do practice questions. And because you're at the beginning, haven't done all the topics, you can't necessarily do full exam papers. Although if you're in year 13, you can do full AS papers. And there are lots of issues with topic questions. So we just need to be aware of the issues. There is a limited supply. So if you're very conscientious, you're going to run out. If you're very conscientious, and like, for example, now, like my year 12s are saying, oh, I tried to do questions on bonding because like, I tried to recap, ionic bonding and covalent bonding. And then there's all this stuff on shapes of molecules and intermolecular forces. We haven't done it yet. So that is another issue. So we can take away from that and go, okay, I'm going to do chapter questions instead. I'm just going to answer questions about halogens today. That's it. And then I know I won't get anything else. But when we do that, it's not like a real exam. They're not exam questions. And then when we do past questions or full marks, full exam questions, the other issue we have is this one. Mark schemes aren't written for students, right? They're written for examiners. They're not even written for teachers. They're written for examiners, and we have to go through training, and we get it wrong. Like most of the people that I know that are examiners, nearly every year we go through the training, and we will have to go back and do something because we've been told by the person above that actually we need to do it like this. So people with 20 years experience using the exam scheme we've got are still looking at some answers and going, I don't know. Is that a 4 or a 5? I'm not actually sure. And I have to send it on to a head person. So what chance have you guys got with 6 months experience, it's hard. So that is why you need to seek feedback more. And when you get feedback from what you've done in school, don't hide from it. Okay? Don't hide in your lessons. Be a pain in the ass to your teacher in a good way, not in a pain in the ass like I didn't do my homework or a pain in the ass um, sitting around looking at your phone. I mean, a pain in the ass, like, I don't get that. Please, can you explain it? Can you give me some more examples of that, of questions on that? Can you explain why I didn't get this mark? Not in a confrontational way, right? But in a, I looked it up and I still don't get it way. Um, and remember how much you can do on your own, even if your teacher is like maybe confusing you or you don't have a good relationship. So you can do a lot independently, but independently doesn't mean completely with no help at all. It just means knowing how to seek help and questions to ask. So we've got synoptic thinking, we've got speaking, voicing, asking, doing, proactive. Just basically get yourself super uncomfortable. Make us don't be afraid of looking like an absolute idiot. Um, because at the end of the day, do you really want to go through your whole A level thinking, yeah, nobody thinks I'm an idiot, and then come out with a C when you could have been asking all those questions and coming out with an A? That's how you've got to look at it. You've got to be uncomfortable to get anywhere. So if we've got that problem with topic questions, um, a quick point about things on my website. I still haven't taken these booklets and practice papers like off sale because I've been so busy tutoring and doing everything else this term. So you can take advantage of my procrastination and get a bargain because currently all of last year's predicted full exam papers, like practice paper ones, so I've called them practice papers. They're on the website as predicted papers. They are 2025 predicted papers, so obviously they're not for next year, which I will write more. Um, but they are very, very useful as questions you haven't seen before. Because the problem with topic questions is you do them all to learn all the topics. And then if you're very conscientious and you've done all the practice topic questions, it means that when you do practice papers, exam papers, timed conditions, you've already seen them. Um, and then it's not really exam conditions. And then you do the real exam, you're like, whoa, it's like nothing I've seen before. Well, yeah, that's the point. Like, that is kind of the point, do the mocks. Oh, it was like nothing I'd ever done. Yeah, every exam is going to be like nothing you've ever done. But the more practice we do, the less scary it's going to get. There are also in there extended response booklets. So some people asked about 6 mark questions. I have booklets that have 20 examples of 6 mark questions. And then rather than just having a mark scheme, because those mark schemes are just like level of response, 2 out of 4 or something, they actually have like a example answer and they have like key vocabulary to help you with that. And then there's also calculations booklet. So if you want to practice calculations, if you really want to practice calculations, I have something better, which I'll mention. Um, there's lots of free resources on my website as well. I mean, they were only like £1.50, but there are also free things like my multiple choice questions, which have video walkthroughs, so you can kind of understand them a bit more. There's a couple of free mini courses for students who are just in year 12 or year 13. And the retrieval practice quizzes are always available up there, as is my email list. So my email list, I just send out a weekly quiz for year 12 and year 13. You can do both of them if you're in year 13. There's no reason why you couldn't do the year 12, especially if you felt like you just needed a bit of a boost, or if you forgot all of your early content. I've also got some like membership options. So I don't actually have any room in my gold membership. That's my group classes. They are usually, as far as I know, they're currently full. Because usually I have had occasionally have people drop out, but then I usually have somebody popping straight in because they're only in groups of 6, so they are small. And I know a couple of you here do my group classes as well. Bronze membership, you can try that for free. So if you wanted to just get some practice questions, you can try that for 2 weeks for free. Um, and what that has, as it says, is like topic checklists. So what this does is help to avoid some of the overwhelm of I don't know where to start and I don't know what to do, because it tells you where to start. You start in the first topic and you do the practice questions, right? After you've looked at the topic checklist and reminded yourself what's in that topic. And then there is a hour-long video for each topic. And that's a recorded from a couple of years ago exam masterclass. So it's basically, right, now that you've remembered the basics about bonding and structure and you've remembered the difference and the definitions, now we're going to look at where could this come up in a weird exam question? What do we do? What do people get wrong? And that kind of thing. Um, and then the silver membership, I mentioned about seeking feedback. So I know that not every student gets the feedback they need. And I do know also that teachers are incredibly busy. Um, they have a lot to do. They don't have time to write their own questions, and they don't get a lot of time to give good feedback. So I introduced this year. I am limiting it because there's only one of me. At the moment, I think I've got 4 students signed up, and I'm probably going to cap it at around 20. So what this is you get all the online stuff. So you get the topic chess list and the practice questions. And what I find is either two things. One, students forget to use it because they're busy, they've got other things doing. So they're paying for something they're not even using. But also they don't really know, just from doing the practice questions and the videos, how good their exam technique is on a particular topic. So what we have is we have a monthly focus of like particular topics. So with my year 13s in October, we were focusing on redox, energetics, and carbonyls and alcohols. So we have like a inorganic, a physical, and an organic focus. We group it all together. At the end of the month, after you've focused on those topics, you get an assignment, which is basically an assessment. It is timed conditions. So you know what it's going to be on. It's going to be on stuff that you've already done. It's about 50 marks. It's multiple choice and long answer. And they are questions that I've written as an examiner and a teacher who's been writing resources for a long time. So you won't have seen them. Obviously, they're not going to be completely weird and off piece. They're going to be in the style of your exam board, but they are not ones that you've seen before. And then you send it to me and I mark it and I give you feedback. And I do 2 ways that I give the feedback. Well, 3 actually. So I actually write on it, classic tick, cross, comments, classic marking. You also get full video walkthrough. So you get me explaining every question. So that after you've done it, if there's something you still don't know, you can check it. And you also get like a little feedback sheet that just gives a summary of like where I think you're at, what things I think you should possibly focus on for revision. So, like I said, I'm trialing it out. It's working quite well for the students that I've got so far, and I'm obviously also using it in my group classes so they get the same thing. If you're interested in that, you can find it on the website, but if you're confused about where to find it or you've got any other questions, just email me. I'm also going to start doing personalized mock exams this year. So what that will be is you tell me the topics that you want to do a mock exam on, and I will be again using like unseen questions, producing them because this is something that I've been doing a long time. And then that means that you get to sit like a bigger exam, more like a sort of hour and a half kind of thing, and get that recorded feedback. That would be a bit more expensive, the mock exam service, because it takes a bit longer to put together a full mock exam than it does the monthly assignments because they're not as bespoke. Does this automatically come with the silver? Does what the marking and all that? Yes. Yeah. The like I said, you don't get with the silver, you don't get to choose specifically. I do ask people what they've been doing in school so I know what everyone's done. You won't get assessed on anything you haven't covered yet. You will also know what's coming because it's every month there's a little booklet that tells you what to revise that month. Um, so there won't be any like massive surprises. You don't get to say, please give me a test on this, because that would just be way too much admin for like individual assignments every time. It's different for year 12 and different for year 13, obviously. I don't, and it's obviously exam board specific as well. So I won't ask you something that if you're doing OCRA, I don't ask you something that's on the AQA exam board. But feel free to email me about that because I have gone a little bit over time. I've got a little bit of time for questions and also a question for you as well, which is simply, I think some of you have already mentioned this a little bit when I asked about what you could do to push yourself a bit more. Um, so I think a lot of you said speaking more, yeah, and actually um, set yourself a reminder in your phone. Like next time you find out when your next chemistry lesson is. I sometimes will just give a target to a student like one a week, one question, just one per week. If you are a very shy student, that's already enough of a target for you. I am going to ask one question. You could even plan it so that you're ready, so you don't have to think of it in the lesson. Um, Questions. What kind of math skills do you need to be confident with to get A star? That's a really good question. I do not have A-level maths. So obviously I did do physics, so I have math skills. I've done chemistry, so I have math skills. But math skills shouldn't be holding you back, and if they are, it's probably practice. And it's also more basic math skills than you probably think. So when people say, oh, to get the A star and the A, oh, I need to be able to do logs and I need to be able to know how to do the Arrhenius equation. No, because the Arrhenius graph is really easy. And if you practice those questions, it's the same most of the time. Actually, what you really need to know is like ratios, standard form, make sure you get at those. These are the things that are important in chemistry. Um, Rearranging equations confidently, working with ratios, like understanding how they link to things like percentages, things like ratios when you do ice tables for equilibrium, that kind of thing. Those are the math skills that you need. Balanced equation ratios, titrations, 2 to 5, 1 to 3 ratio, that kind of thing. Those are the things that are much more important. Dilution, how do I dilute a solution? I use ratios to do that. Or like how to multiply something. All those things. Um, how to deal with feeling like you're bad at chemistry. Hopefully, this was one that was in the questionnaire. Hopefully, I've sort of helped with that. Is to one, appreciate that everyone's going to feel bad. I also think if you're feeling bad, so a lot of people will say you need to change how you talk to yourself, which is true. So you have to start talking to yourself like you're like being a friend to yourself, instead of always being a critic. Now, the reason that people don't continue doing that or that it doesn't work is because it doesn't work straight away, just like any of the things we've talked about today. You can't just walk into your next chemistry class going, I am amazing. It's going to be great, and you won't believe it. No, of course you won't. Okay. But if you constantly make habit, so this is how we get rid of the imposter syndrome. If you make the habit of doing things like, remember that thing that I was crap at that I'm now good at. Remember where you came from. Don't focus too much on the final result. If you're always concentrating on how to get an A star, you won't get there. You need to concentrate on how can I just do this one little thing. So give yourself smaller targets and realize that everybody feels a lot similar. You have to be quite good at something to be an imposter, to feel like you're an imposter. You have to have got high up enough amongst that group of people. So you do deserve to be there because you got the grades to get in and you are there. So therefore you shouldn't be feeling. But I know it's not as easy as that. It's a habit, self-talk. Get up in the morning and give yourself a high five in the mirror before you leave. Um, and preventing overwhelm and task paralysis, that's another one. So we do get overwhelmed. I get imposter syndrome. I hate social media. I hate it. Okay. I hate going on it. I hate have to think of things. I hate the constant changing of the algorithms. I get totally overwhelmed. And it seems to be like it's the only way you can get content out there. So I don't like it. Um, and so the way to get out of that is to take away some decisions. Okay, so if you're overwhelmed by tasks, these are the things that you could farm out to AI and technology. These are things that you can take some of the decisions away to stop you getting paralyzed and overwhelmed. So you sit down to revise. If you plan ahead and you've already decided that you're going to do something at a particular time, then you're going to do it at that time and you put it in your calendar. You don't go, I'm going to probably revise um, carbon aisles this week, or you don't wait for your teacher to tell you you've got a test on something. So picking a time when you're going to consistently do something and then just make a whole list of topics, stick numbers next to them, and ask your phone to give you a random number, or ask Google or ChatGPT to give you a random number, or ask ChatGPT to give you a random topic from the first year, and then choose the task that you're going to do to revise it. So by taking some of that decision away, it stops you getting completely paralyzed. Um, yeah, balancing year 12 and year 13 content side by side. Yeah, you can use the retrieval quizzes and the linking. Okay. So some things go very neatly together. Um, like obviously first year energetics and second year energetics. There's organic chemistry that links together. Always link your organic. And to get through all the topics. I also have a planner, study planner, which I usually bring out a bit later in the year, which you can download, which helps you see the different links together as well. There was a question about infrared and I've lost it. Oh yeah, infrared spectroscopy. Where can I find the pattern? Um, Struggling to find what they look like. Is that because they're not on the exam papers? I know OCR like has pictures and yeah, I could tell you what an infrared looks like. Stupid. C double bond O, OH, stuff. Don't overcomplicate infrared. So it's not all going to be like that, but most of it is. Right. So wide, short, OH, steep, and 1700 for C double bond O. Um, You can get them. I shouldn't be advertising other sites, but hey, Chem Sheets have very good question booklets, and it's a very small subscription. I think it's like £12 for a year. Or you can do free 2 weeks of my masterclasses, and then you can go and look at my organic analysis. I also have on YouTube lots of organic. I've done at least two past um, like online classes like this that were focused on organic. I have actually run out of time. I just realised because I've got this other lesson at 4:30. So I'm very sorry, but you can, of course, send me any questions that you've got. Um, I've had a few organic questions. How to get better at skeletal formula, do them, practice them. Um, right, just take a bunch of organic compounds and draw them. And then to check you right, just put in Google, like name it, and just look for the skeletal formula. So all you can do is practice. Um, Again, there is like organic lessons where we talk about that as well on the masterclass stuff. So if you want to try it for free for 2 weeks, if you're worried, oh, I'm going to try it for free and then she's going to charge me, well, yeah, it is automatic. Set a little reminder on your phone, on your calendar to go back after like 13 days and cancel it. And then you won't have to. But if you want to pay £5, you could, and then you could get it for another month. All good. Even if you just wanted to use it to help you with mocks. Right. I have to go. If you've got any more questions, feel free to email me. Um, go on the YouTube channel and look as well because there are quite a few. There's like a playlist of organic chemistry. There's a playlist for calculations. There's a playlist for practicals. So I know lots of people asked about practical work as well. And then you can look at those. All right. Goodbye, everybody. I'm gonna stop the share and I hope you have a lovely rest of your half term. All right. Bye bye.